So the big picture for part D is we have a graph. Let me see. Okay, this is the big picture here. F double prime is less than 0. That indicates that we have a concave down graph. And this is basically an application for the part D, application of a linear approximation. Because if I have a graph that's concave down and I have a tangent to a graph, that tangent is always going to be, any point on that tangent line is going to over approximate, right? Yeah, because it's concave down. Right? If I want to find, let's say this is f of 5, if I want to find f of 5.1 versus the linear points f of 5.1, that linear approximation is always going to sit above, it's always going to over approximate. Okay, and then if I had a secant line would be a line that is hitting 2 points. This secant line is now going to under approximate a point on the curve. So that's what they're getting at for part D here, is that if I have a concave down graph, any tangent line is going to over approximate a point on the actual graph, and any secant line is going to under approximate a point on the graph.
What do you mean by the under approximate? Like, is it referring to the slope, or for the secant line? I understand the tangent part, but for the secant line, by underestimate, do you mean like the slope? It's not asking about MVT.
Not quite. So let's say this is the graph here, right?
Okay.
And let's say f of x is the curve, and let's say y of x is the line. And let's say the point of tangency was at 5, right?
Right.
So
okay.
if I were to compare y of 5.1 versus f of 5.1, which one will be the higher value?
Y of x.
Yeah, exactly, because it's a tangent line that is skimming this top of the curve. No matter where I draw my y of x, because the curve is concave down, this tangent line is always going to be higher than any point on the curve.
Okay, so it's basically comparing the y of x, like dashed lines.
Right. Okay. With a point on the curve. And then likewise over here, if I have a secant line, because the way the graph is shaped, the secant line is always going to be under approximating a point on the actual curve.
Okay.
So
that makes sense.
Yeah. Yeah. So now that I see the big picture, we can go through the problem here.
All right.
So suppose that f prime of 5 is equal to 3. So we know the slope of the f graph at 5 is slope of 3. On the interval from 5 to 8, use the line tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. So the idea is that if I can show that this tangent line at 7 has a y value of 4, then for sure, any point on the curve at f of 7 must be lower than 4. So I think that's what, hopefully we can get to this conclusion here. We can show that, okay, if the tangent line is giving me a y value of 4, then the curve must give me a point that's lower. Okay, so let's build a tangent line first. All right. Want to do the help session, or do you want to finish up help session? We're on page 5 in the packet 2. So tangent line, my point is, well, at 5, my tangent line has an order pair. Well, the order pair is 5, -2. Yeah. And then slope, f prime of 5 is equal to 3. Okay, so we create our tangent line, y plus 2 is equal to 3 times x minus 5. If I solve for y is equal to 3x minus 15 minus 2. So y is equal to 3x minus 17. So this equation is going to give me any point on this tangent line. So if I want to find y of 7, let's see what y of 7 gives me. Y of 7 gives me 7 times 3 is 21. 21 minus 17 is 4. So since y of 7 is equal to 4, and we know that f of 7 has to be less than y of 7, we can therefore conclude that f of 7 must be less than or equal to 4. Since the tangent line to the graph, since the graph is concave down and we have a tangent to a graph that's concave down. So that's the first part. Second part, use the secant line to show that f of 7 is greater than or equal to 4/3. So if I can, I think what they're going to try to get at is if I can show that this approximation using the secant line is 4/3, then I know that f of 7 must be higher than 4/3. So I'm going to create the equation of the secant line here. So secant line, all I need is the slope and the order pair. So slope, I'm going to pick the 2 points that they highlighted for us. So 5 and 8. So 5, -2, and 11, 3. And then if I want to create the secant line equation, it doesn't matter which point I choose. I can either choose 5, -2 or 8/3 to do point slope form. But I'm just going to choose 5, -2. It really doesn't matter though. They're both going to give you the same equation. So y plus 2 is equal to 5/3 x minus 5. Okay. Let me get y by itself. So if I plug 7 into the secant line equation, let's see what do we get. I get 10/3 minus 6/3, which is 4/3. And because my secant approximation, my secant line is giving me a y value of 4/3, there's no choice but for the curve to experience a y value greater than 4/3.
And then for the explanation for that, would you just say because the secant line is under approximation,
Right.
the other curve has to be greater?
Mm-hmm.
Okay. All right, that makes sense.
Mm-hmm. Good. Okay, do you have any questions from the packet?
Oh, actually. Page 22.
Mm-hmm. Okay, which one? Yep. So solving differential equations. Right, so we always want to try to see what we can do to cross multiply to begin with. So I'm gonna go ahead and do that. Cross multiply, I get dy is equal to so first things first is we cross multiply to make sure our dy dx's are locked into their to their ideal locations. And then next is separation of variables. We want everything associated with y on the left, everything else on the right side. So this 3 minus 2y is being protected with a set of parentheses to help remind us that anytime we move that y over, we have to move this whole thing over along with it. So we'll divide both sides by 3 minus 2y. Okay, now that after we do this, we should have full separation of variables. So the right side, we can just use first theorem. We know that f double prime will rise up to f prime. But here, we got to go through the correct integral rule. And there's multiple terms down here. We can't just rely on u substitution. Well, we can't rely on an integral rule to begin with, so we'll do u substitution. And our u value is going to be that 3 minus 2y in the denominator. We pull the negative 1/2 out in front, and now we're left with 1 over u du, which we can handle using natural log rule. 1 over u becomes natural log absolute value of u. The negative 1/2 stays out in front. And then the f double prime will rise up to f prime plus c. We can replace the u back in terms of the original variable. I'm going to begin my cleanup process. I do want to solve for c. but I'm going to just go ahead and clean this up here. I know that -1/2 eventually is going to have to be on the right side anyway, so I'll multiply everything through by -2. Just to move that over. I'll go ahead and try to solve for y at this point. So I want to undo the natural log. By undoing natural log, that means I'm going to raise both sides with e as the base. That's going to allow the e and natural log to cancel out. I know that e to the exponent plus c is same thing as e to the exponent times e to the c. And that e to the c can just be its own constant here. So I can convert that e to the c to just be one big constant, pull that constant out in front, drop the absolute value. Now I can move things around too. Actually, maybe at this point I can just go ahead and I'll go ahead and solve for y. So -2y. Divide everything by -2. Now c divided by -2 is same thing as -1/2 times c, and we know that anything times a constant is still a constant, so I can just drop that -2 there. So now that I have my equation, I'm going to plug in 0, 1. Zero in for x, 1 in for y, solve for c. Now my f prime of 0 is -1. I'm sorry, h of 0 equals 1. I did, yeah. So then f prime of 0 is -1 because that's the order pair given to us. So subtract 3/2 from both sides. 1 minus 3/2 is -1/2. Okay, divide both sides by e squared. C is equal to -1 over e squared. All right, so now that I have my c value, I'm going to go ahead and plug that in. And then now I can use that to find h of 2. I'll put that up here. Okay. On 2n for x. F prime of 2 is 1. Oh, wait, I'm sorry. C is -1 over 2e squared. My bad, 2e squared. So there's a 2 here. All right, so now that I can merge this e to the -2 can come down as e squared. E squared and e squared becomes e to the 4th. So -1 over 4 e to the 4th plus 3/2. All right, -1/2. Okay, so we do separation of variables. We find the antiderivative, we solve for the c value, and then once we have our updated equation, then we may use that equation to find the y value that we're really looking for. Yeah. Mm-hmm. Okay, to estimate p double prime of 5. Well, p double prime of 5 is basically involving the slope of p prime. So we can just find 2 points that's close to 5, and then just find 2 points that's close to 5, and then just find the slope, because the rate of change of p prime will give us information about p double prime. So I just found the y values at these points here. So 3.0 minus 4.7 over 4. That gives me -14 over 40. Hundreds of rolls per day squared, or we can multiply that 100 through and make it -42.5 rolls per day squared, either way. But that negative indicates that the rate at which the paper is sold is decreasing. So anytime we see anything dealing with a second derivative, it's always because that positive or negative value is always indicating that the rate is increasing or the rate is decreasing.
There's a specific reason.
No, that's fine. You can do -1.7 over 4. It's just this, yeah, they're the same thing.
The explanation.
Well, we want to be able to indicate what's happening with that negative sign. If you just say changing, it's still not as clear because the changing could be either increasing or decreasing. So yeah, so we do want to indicate that decreasing word. Mm-hmm. I'll have another help session tomorrow morning.
Do D on page 18.
Mm-hmm. Okay, so evaluate m double prime of 7 minus 3t. Oh, D, let's see. Okay, this one here. Okay.
Hey, Mr. Yang, I'm about to head out.
All right, sure. See you in class.
Thank you.
So this is an application of Rolle's theorem here. If I want to find out where m double prime of c is equal to 0, I mean, it'd be nice if I have m double prime values here, but I don't. I have m prime values. So we know m double prime is essentially referring to the slope of m prime. So if I can find 2 points where m prime has the same y value, then in order for me to get from this point to this point, the graph has to either go up and come down or go down and come up. And in that motion, it's going to have to experience a slope 0. And because of that slope 0, we can guarantee that, that there's going to be a point somewhere between between 4 and 7, where the slope of m prime is going to experience 0, and that's Rolle's theorem.
So you don't need to show like the slope from the.
You could. You didn't have to though, because it's kind of understood that if the 2 points are the same, the slope will be 0. But if you didn't do that, if you just rely on mean value theorem, you would still get the same result. You would get full credit there as well. And yeah, so you could have gone through and picked out these points, showed that the slope is 0, because the slope is 0. So yeah, you could have said mean value theorem and not mention Rolle's theorem and still be correct.
Okay, so it's just like not necessary.
Not necessary. But if the problem indicates Rolle's theorem, then you do need to know what they're referring to, that they're trying to get you to get that slope 0 to occur. But you don't have to say Rolle's theorem in your justification. Mean value theorem would be fine.
Because I'm gonna see her soon. Can you do B on page 21?
So we have dw/dt. We have to make our way down to the derivative below that. Now, this is in terms of time. So because this is in terms of time, this is kind of a little bit of kind of related rates process here. But if I try to find the derivative of time with respect to itself, then there's no I mean, technically there's a dt over dt, but that kind of drops out. So 2t just becomes 2. W minus 9 stays, 2t stays, and then W minus 9 becomes dW dt.
Why are you supposed to use the approximation for the? I was confused why like the approximation from the A, why you're using that for B.
It says determine your approximation from part A.
Oh,
Yeah, so we have to rely on part A since we don't have any other information to get to the amount of watermelon at 3 weeks. So we have to rely on that 14 there. So that 14 gets plugged in to my dW dt formula. So with the that we'll replace that dW dt. Yeah, we have to use that. You had kind of like a nested kind of process here. But eventually we get to dW dt. At that moment in time is 30. So that's what's happening at that moment in time. Plug 30 in for dW dt, and we get 190. And that 190 is a second derivative value, which indicates concave up. If the graph is concave up, then anything that is tangent to that curve must be under approximating.
so you're just using like.
Yes, to find concatenate,
Okay.
right.
So it doesn't matter that it's just an approximation.
It doesn't matter, right? Now, it would have been easier if they just gave us the ordered pair rather than making us find it, but this is our best value, so we have to use that.
So if they did give you a value, would it be a value for 3 or a value for 3 weeks or another?
It would be a value for 3 weeks.
Okay,
Yeah.
but I guess that makes sense because like, then you would already know whether it was an overestimate or an underestimate. Okay. I think it's like.
Okay.
Yeah.
Yeah, and then tomorrow we'll do the morning help session. The morning review worksheet.
So I think there's a middle of a data meeting this Wednesday.
Okay. Oh, wait, Wednesday.
We need to. I.
No, we can. Yeah. If worst comes to worse, we could always use the other room, but if we can make it Thursday, that would be Thursday or Friday would be the best, but I don't know. You tell me. You can let me know. Okay.
See what.
Because because I need to do a health session for my AB students. They're having a test on Wednesday. But I can always open up that 3303 room. And then, but you may not have a projector, but if you give me the PowerPoints, I can print out the slides and just have everyone have the slides in front of them.
Okay, I think because we wanted to do a Kahoot.
Okay,
to get
okay.
This meeting, so I think it might be easier if we have it.
Yeah, I'll do it Thursday.
Um.
Yeah, or double check.
Thursday or Friday.
Thursday or Friday, yeah.
I'll ask you about it.
Sounds good. Okay, thank you, appreciate it.
Yeah.